Hello and welcome to another Ginger Mathematician video. So today we're going to focus on all of iGCSE inequalities, and it will include some linear programming a bit later on. So we've got a mixture of paper 2 questions here and paper 4 as well. So let's get started with question 12 here. So x is an integer. Remember, that's the most important word to remember on the course. Remember, an integer is simply a whole number. So we're looking for whole number solutions for the following inequality. This is a combined inequality here. So notice we have an inequality here and an inequality there as well. And by this, we need to work out the values of x. Now, the way I tend to approach this kind of question is actually solve in parallel. So what do I mean by that? Well, we're going to solve both sides of the inequality at the same time. Now, just like any equation, we want to get the x on its own. So again, we have to work away at that central term here, 2x minus 1, to get x on its own. So the first thing we're going to do on all sides is going to add 1 on all sides to make sure we can remove the minus 1 here. So minus 3 plus 1, that's equal to minus 2, less than or equal to. Now, because we've added 1 here, this cancels, leaving us then just 2x, and then 3 plus 1 here is equal to 4. So we're just going through this step by step so we actually get the x on its own. Notice we have 2 lots of x at this time. So what's the opposite of multiplying by 2? Well, we divide by 2 on all sides of this inequality. Minus 2 divided by 2, that's just minus 1. We leave the less than or equal sign. Now the 2 here cancels, leaving us with just the x, which is exactly what we wanted. And then 4 divided by 2 is equal to 2. So that's the inequality solution to the answer. However, we need to read the question carefully. We need to find the values of x. So this on its own would not give you all the 2 marks, but we need to then understand what this means to write down the answer. So if I say this in words here, this essentially means minus 1 is less than or equal to x. So this is what this symbol means up here. You're going to get lots of practice in this video. And x itself, so now we're looking at this part of the inequality, is less than 2. So give yourself a moment just to read that sentence. Minus 1 is less than or equal to x, and x itself is less than 2. So what answers are allowed here? Well, we can have minus 1 because it's less than or equal to x. We can have 0 because minus 1 is less than or equal to that x, to that 0. And we can have 1 as well. However, x must be strictly less than 2, so we can't include the 2. And so these are the only 3 numbers that fit the sentence I've just described there. So we get all 2 marks for putting in minus 1, then 0, and then 1. So you can have a look at the answer. As they say, final answer, that's the thing that you're allowed to have. And again, you get the method mark for what I showed you a bit earlier on. Now let's have a look at question 13 here. So we need to solve this fairly difficult looking inequality here. Now, there's a couple of rules that I generally use with inequalities. Number 1, we need to treat it like an equation. That's the first thing to remember. We treat it like an equation. However, if we ever multiply or divide by a negative number, and we will see this at some point in this video, then we have to switch the sign. Now, if you're wondering why that's the case, then do check out the video above because I go through the theory of exactly why we follow these 2 rules. But in this video, I'm focusing on that exam technique and making sure we can answer the questions. So let's get started with this. Again, we follow rule number 1. We treat it like an equation. This divide by 5 is kind of annoying. What's the opposite of dividing by 5? Well, we times by 5 on both sides of the equation. We times all this by 5. 5 times 4 is 20. 5 times minus 3x is minus 15x, greater than or equal to. This 5 cancels. then leaving us with just 6 minus x. And now this is just the idea of going through, being careful, treating it like an equation, and don't forget rule number 2. So which side has the fewest amount of x's? Well, we have a minus 15x here. So what's the opposite of minusing 15x? Plus 15x on both sides. This cancels, giving us here 20 greater than or equal to 6 stays as it is. Again, we're collecting terms here. Numbers and x's are different kinds of terms. And minus x plus 15x gives us plus 14x, like so. Again, we're going to work our way along to try and get this x on its own. The plus 6 is annoying. What's the opposite of that? Minus 6 on both sides. 20 minus 6 is 14, greater than or equal to, and the 6 cancels, leaving us with just 14x. And now we want to get the x on its own. What's the opposite of timesing by 14? Well, we're going to divide by 14 on both sides. 14 divided by 14, that just gives us 1 here. And then we get what we want on the right-hand side, leaving us 1 is greater than or equal to x. Generally, we like the x's on the left-hand side, so we can just flip this over. So this statement is the same as saying x is less than or equal to 1. Okay, I'm going to say that out loud again. 1 is greater than or equal to x means that x must be less than or equal to 1. So this flipping is allowed as long as we follow the inequality here and the sentence I've just said. So our final answer is x is less than or equal to 1. Again, you can have a look through the answer here. 3 marks worth on this. So again, when it does come up on the iGCSE, which it does from time to time, you want to be getting those 3 marks. So you can see the method marks here, and then our final answer, x is less than or equal to 1. All right, let's move on to an inequality diagram here. So in this case, we need to write down the inequality in terms of n. So that's important. We're using n in this inequality, shown by the number line. Okay, so first of all, we're starting at this -1 point. Notice we have an open circle, and that means this is a strictly less than or greater than symbol. So we'll be using either the less than symbol or the greater than symbol. If it was a closed circle, as in a filled-in circle, then we put a line underneath instead. Now let's have a look at what's going on here. Well, I've got -1 and everything bigger than -1. So if I'm going to write this as an inequality, I'm going to put n, because we need to use that from the question. It's going to be greater than, because we're going to the right here on our number line, and then -1. So again, 1 mark question, getting a mark just for writing down the answer, but hopefully that logic works through. Again, we're going to look at that also in other questions too. So there's the answer, all equivalent. So what they mean here, the OE, you could write it the other way around, and this would also be correct as well. Okay, now we've got another solving question, again question 15 here. Again, we approach it, those 2 rules, treat it like an equation, and don't forget about dividing or multiplying by negative numbers. So, which is the fewest amount of x here? 4x. What's the opposite of adding 4x? Well, minusing 4x from both sides. 12x minus 4x is 8x. The -3 stays as it is, so we're focusing on x's, not the numbers. And we have our greater than or equal sign. 4x minus 4x cancels, and then we get 13 here. Again, we're just going through this nice and steadily. We want to get the x on its own. -3, kind of annoying. What's the opposite of that annoying -3? Well, +3 on both sides. This cancels, giving us then just 8x greater than or equal to 13 plus 3 is equal to 16. And we're almost there. We just need to get rid of this times 8. What's the opposite of timesing 8? Divide by 8 on both sides. This cancels, giving us x on its own. We're there finally. Excellent. Greater than or equal to 16 divided by 8 is equal to 2. Again, we don't need to do any switching here. We can leave the answer as is. So when we have to solve, we can just leave it as an inequality. That is absolutely fine. Again, there's the answers there and where you pick up that method mark. But make sure you're getting 2 marks on that and 1 mark on that question. Right, on to our next question here. Again, this we have to read it quite carefully. Find all the positive integers that satisfy the inequality. Kind of strange language, but we'll talk about that once we've solved. We're going to do that first and then answer the question. So we have 3n minus 8 is greater than 5n minus 15. Okay, what do we have the fewest amount of n's in this case? Well, that's going to be the 3n here, because 3n is smaller than 5n. What's the opposite of adding 3n? Minusing 3n from both sides. This cancels, giving us just minus 8. Greater than 5n minus 3n is 2n, and then minus 15. Now we focus on this minus 15, kind of annoying. I think you can probably see the pattern in these questions. What's the opposite of minus 15? Well, add 15 on both sides. Minus 8 plus 15, so think of it like temperature. Minus 8 degrees, very, very cold. Gets 15 degrees warmer. What's our new temperature? That's going to equal 7. Then we get greater than, 2n stays as it is. Minus 15 plus 15 cancels, which is very, very nice. And then we need to work out what n is here. It's the opposite of timesing by 2, dividing by 2 on both sides. This cancels, giving us n here. 7 divided by 2, that's equal to 3.5. So we can always flip this around. I generally like working from left to right. It makes a bit more sense to me. So this is also saying the same as n is less than 3.5. 3.5 is greater than n is the same as saying n is less than 3.5. Now let's go back to the question. So find all the positive integers. So positive whole numbers. That is true here. Okay. Now, first of all, 0 is not considered a positive integer, so we can't include 0. Does 1 fit this statement? Yes, it does. So 1 works. Does 2 fit this statement? Yes, it does. Does 3 fit this statement? Yes, it does. Does 4 fit this statement? No, it doesn't. Okay, make sure you're paying attention. So remember, n is less than 3.5, so 4 is too much. Therefore, the only positive whole numbers that fit is n is 1, n is 2, and n is equal to 3. So leaving it as this is not good enough for the 2 marks. You need to state explicitly what those numbers are. Okay, and on to part B of this question. So this is into the linear programming aspect of the course. Again, you need to be very familiar with this. It doesn't come up very often, but when it does, it can be quite a lot of marks. So the region marked R is defined by 3 inequalities. So these 3 lines, basically. And we need to find these 3 inequalities. Right, so first of all, let's talk about this dotted line. So you'll notice sometimes there is a dotted line and sometimes we have a solid line. If there is a solid line, our inequality is going to be either less than or equal to or greater than or equal to. It will have a line underneath, basically. Whereas when we have a broken line or dotted line, it will either be a strictly less than sign or a strictly greater than sign. So that's the first thing to realize when I'm looking at a question like this. Now, let's go through each of these inequalities one at a time. We want the region in the middle. So notice this x equals 4 line, we want to go to the right of this line. If we go to the right, notice these x numbers get bigger and bigger and bigger. Therefore, which of these symbols do I need to use here? Less than or greater than? Well, we need to use the greater sign because we're going to the right of that line and the numbers are getting bigger. Therefore, this is going to be x is greater than 4. We're copying down the equation and then adapting it by putting in an inequality. Okay, let's do our next one here. So let's take this next dotted line. Now, because it's a dotted line, this is either going to be a strictly less than sign or a strictly greater than sign. Okay, so with this one here, notice we want to go upwards here. And if we're going upwards, do our numbers get bigger or they get smaller? Well, our numbers get bigger here. Therefore, we need to use this symbol, the greater than symbol. So we get 2y is greater than x minus 4. This is all the question's asking, taking these equations and then make it an inequality. Now let's look at our last equation here, so this more complicated looking one. Notice we have a fixed line, so a completely fixed line all the way through, not dotted. Therefore, we're using one of these two symbols, less than or equal to or greater than or equal to. Notice we want to go downwards to go into the region, so our numbers getting bigger or smaller. The numbers are getting smaller, therefore we need to use this symbol in this equation. So we have 10y plus 8x is less than or equal to 80. And we've got our three inequalities that define the region, that triangle in the middle. Okay, and a nice little twist on this question right at the end is write down the largest value of 3x plus y in that particular region, in that triangle, for integers x and y. Now, because we're timesing the x value by 3, we want the largest x value possible within that region. So if we go back to our triangle here, what is the largest integer value, whole number value, that exists here on the x-axis? Well, notice 8 just falls outside of this triangle, but 7 does fall within the triangle at this point here. So the largest x value within this triangle is at 7, 2. So this coordinate here is 7, 2. That fits into that triangle. So that's when x is 7 and y is 2. If I pop that or substitute that into here, so wherever I see an x, I put a 7. Wherever I see a y, I put a 2. We have 3 lots of 7 plus 2. 3 times 7 is 21 plus 2. And then that gives us our final answer here of 23. Nice little twist they've been doing recently on these iGCSE 0580 questions. Again, trying to get you to find the largest value with a specific expression that they give you. The key thing to remember, if you've got a 3x and a y or an x and a 2y, you look at the one that's being multiplied here, so 2 or 3, and then look at the largest value for that coordinate. Okay, so you can see the answers there. Again, you can see all the work it was necessary. Again, one of these kind of meaty paper 4 questions where we're getting 7 marks, which could make the difference between B and A or even A and A star. Right, let's look at our next paper 4 style question here. So it starts off paper 2-esque. So we need to solve this equation. And we're going to use those 2 rules, treat it like an equation, but at the same time, watch out for dividing or multiplying by negatives. So we have the smallest amount of x here, well, that's just 1x. What's the opposite of adding x? Well, minusing x from both sides. This cancels, leaving us with minus 3. Then we have 5x minus x is 4x. 7 stays exactly where it is for the time being. Now we need to remove this plus 7. So what's the opposite of adding 7? Minusing 7 from both sides. Be careful with your negative numbers at this point. So minus 3 degrees, it gets 7 degrees colder. So it's going to be minus 10 degrees. This part cancels, which is what we wanted. Therefore, we have 4x on the right-hand side. And now we need to work out what x is. So what's the opposite of timesing 4? Well, we're going to divide by 4 on both sides. This cancels, giving us x here. And the symbol is going to stay the same for the time being. Minus 10 divided by 4 is just minus 2.5. And you can use a calculator for that. Generally, we do like writing it the other way round here. So I'm going to switch over at this end here and go, well, if minus 2.5 is less than or equal to x, therefore x itself must be greater than or equal to minus 2.5. I suspect in the answers they will accept both. Interestingly, they don't, but I would probably still give 2 marks for this statement as well, since it's true. However, it's useful writing it in this way for next part here, part B. We're going to show this answer on the number line. So the way we do this is we look at the key value, so minus 2.5. We find that on our number line here. Because we have a greater than or equal sign, this is going to be a filled in circle. Notice in the previous question it was an open circle, but here it's filled in. And x is everything greater than or equal to minus 2.5. So we're going to go to the right here. So we draw an arrow. Make sure you do that with a ruler. I definitely did not do that with a ruler, but make sure we pop that in for the 1 mark. You can see, go to the answers here. Again, it should be a straight line, but again, as long as you're showing that information there, you should get the 1 mark. There is also follow through available here. So say we got the first answer wrong, but we used that wrong answer correctly on the number line, you would get that mark for part 2. Right, on to a bit of linear programming here, slightly different style of question. So the line y equals 16 here is drawn on the grid. And the region R satisfies the following inequalities here. And we need to draw in 3 more lines. Notice this y equals 16 is already drawn in for us. So we've kind of already done this part. So we can tick that off. We need to draw in the other 3 inequalities so that we can find and label this region R. However, we need to shade in the region not required in order to show the region R. I'll explain what that means for this whopping 6 marks on this question. Now let's just start this off nice and straightforwardly. First of all, we have x is greater than 2. So the way we go through this is first of all I'm going to consider x equals 2. What does that actually look like? Well, anything with x equals is always a vertical line. And that's going to be at 2. So if we look at our scale here, so we've got a scale of 1s, 1, 2, 3, 4, 5, etc. We're going to go to 2. Now, because we have a strictly greater than symbol, we want a dotted line. So we're going to draw a dotted line going upwards. And my line is a little bit wobbly. You should be using a ruler in the exam. And that then gives us, I'm going to label this x, and we'll talk about the greater than part a bit later on. So we've done that line, we've popped that in. X is greater than 2. Now when it gets a bit more complicated, so we have 2x plus 3y is greater than or equal to 72. Again, I'm going to consider the equation here. So put an equal sign essentially. Now you can do this by a table of values. You could do this by converting it to y equals mx plus c form and then drawing the line. I'm going to show you a quick trick here to do this fairly quickly. What I'm going to consider is essentially the x and y intercepts. So what do I mean by that? Well, when x is equal to 0, so I'm going to pop in x is 0 here. Notice this term is going to disappear. We leave ourselves with y. So 3y is equal to 72. Therefore y, we want that on its own. So we need to divide that by 3. Let me get my calculator out for the first time in this video. We get then the answer of 24. So we know on this equation that there will be a point 0, 24. So that's useful to know. And now we're going to work the other way around. So when y is equal to 0, then we just consider when we've got the x term only. So 2x is equal to 72. And therefore, if we use the calculator quickly, 72 divided by 2 gives you equal to 36. So then we also know that the line crosses at 36, 0. So I'm going to put those 2 points in here. So we have 0, 24. So we're going up in ones here. So 1, 2, 3, 4. So I'm going to pop that in. And then we have 36, 0. So we go along the x-axis and we go 1, 2, 3, 4, 5, 6. And pop that in. And what we do at this point is we can simply just connect up the dots. This is why a ruler is very, very handy, and it saves you a ton of time trying to use y equals mx plus c or a table of values. So all we do in the exam. Now I'm going to connect this up with a straight line, not a dotted line, and we'll see why in a moment. Okay, I'm going to try this as straight as possible. That's actually not too bad. I'm definitely going to be happy with that. Why am I using just a full straight line and not a dotted line? Because we have this line under the inequality. It's greater than or equal to. It's got that equal to part in there, and it's going to be a full straight line all the way across. Now we can use a similar idea for this last one. So we've done these two now. So if imagine we've got y equals 32 minus x. We can do a similar trick rather than using a table of values or something else. So when x is equal to 0, y is equal then just to 32. So we know it goes through at 0, 32. And when y is 0, so I'm copying that equation and making y 0. Then we can do a little bit of equation solving and we can get x is equal to 32. So we know it's also going to go through 32, 0. Making sense because the gradient of this line is -1. So if we draw this in, we're going to pop on 0, 32, 1, 2, and we're going to pop on 0, 32, 1, 2, pop that in, and then we draw a straight line there. Now notice we've got a less than or equal sign, so it's going to be a full line. It goes all the way through. Again, I'm going to try and draw this as best I can. Like so. That wasn't the straightest line in the world, but hopefully we see the idea there. And now we've drawn in our last inequality. So we've done the first part. We've drawn in our 3 extra lines, and we're going to shade in the region not required. Find and label region R. Okay. So let's get a different color for the shading here. Let's use blue in this case. And we want to work out what's not required. Okay. Now, a nice little trick here. If you're ever unsure in the exam, generally it's the triangle that they're looking for. Okay. So we can see the triangle is actually here, but let me just go through the process of what it wants us to do. So, first of all, let's start with y is greater than or equal to 16. So we don't want then anything less than that. So we can shade in this part. So I'm shading in everything that's not required, which is everything less than 16. So I'm doing the opposite of what's seen here. X is greater than 2, so we need to shade in everything less than 2. So I'm going to shade in everything to the left of this dotted line. So shade that in. Now 2x plus 3y is 72. So that was this line coming across, and we want everything greater than that, so I'm shading everything less than that. So that's going to be this part here, everything below this line. Shading down here, make it nice and clear. Shade in this part, and then I want y is less than or equal to 32 minus x. That's this last line we drew in, and because we want everything less than that, we shade in everything that's more than it. So everything that's bigger than this line. So I'm shading lots of it here, but as I said, the triangle, actually it's not quite a triangle here, is going to be the area that we're looking for. So let's shade that in. So our area, region R, let's use a different color here, let's use black. It's going to be dot, 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 dot. It's going to be this line. I've got this part here and there. So let's label that R, and now we've done that for our 6 marks. You can see from the mark scheme it's not actually very clear because of this one here, but it should be this region here, and I've indicated that very, very clearly for the mark scheme. Now here we need to find the integer coordinates x, y in the region that give the maximum value of 2x plus y. So again, similar to the previous question we did here, we want the largest value of x. That's what we're looking for here. So let's look at our region. Let's get the red pen back out. And what's the largest value of x that I can have? So the largest value of x I can have, because this is a full line, is actually this here. This one here. So that is when x is equal to 16 and y is also equal to 16 at that point as well. So we have this point. So the largest value of x, and then I can read off from the straight line here because this is 16, that y would also be equal to 16 as well. So here we're just looking for the coordinates, so we just pop in 16, 16. But notice if they wanted to work out the actual value of it, we just substitute 16 in, and that would give us then 48, like the previous question. But here, they just want the coordinates. So you can see everything that we've done for that particular question. Lots of marks available for a paper 4 inequalities question, which does come up from time to time. Right, on to our next question here, so question 7a. Now we need to actually take the diagram they give us and write down the inequality in x shown by the number line. So notice we've got an open circle here, so we've got either less than or greater than. We have a closed circle here, so we have a less than or equal or a greater than or equal. So how do we write this down as an inequality? Well, notice our limits, so to speak here, are -2 and 1. X will be in the middle here, And then we just put in the inequalities that make sense. So minus 2 here is less than x, because it's everything to the left of being in the middle or in between here. However, at this point here, this is going to be a less than or equal sign. Generally, when you write a combined inequality, they're always going to face the same way. So you're always going to have this or this as you writing it in. Again, takes a bit of practice, but again, as long as you read this out loudly, minus 2 is less than x. That's true. And x is less than or equal to 1. That's also true from the diagram as well. Okay, so if you need any more help on inequalities, I actually did create an inequalities playlist over 3 parts where I go through far more detail of the theory rather than looking at all the exam questions. Again, you can check that video out right in front of you. And if you want to subscribe, then that would be absolutely fantastic. And I'll see you on the next video.